Let's discuss another question from theory of machine. Okay, so here we have, okay, so what is asked is the kinetic energy of the flywheel is asked. So kinetic, because the flywheel is something which undergoes a rotational uh, rot which has rotational inertia, it undergoes rotational motion about a fixed center line. So the kinetic energy of this will be derived from the rotational behavior, and it is half I omega square. So mass moment of inertia into angular velocity whole square. So now mass moment of inertia is given, which is 2000 kg per meter square. What we don't know is the angular velocity. When you start from rest, it is given that it has a uniform acceleration. So the equations of rotational mechanics are similar from and has an anomaly, are synonymous, sorry, with the linear motion. So the rotational velocity is like a linear velocity. So rotational velocity, if it is undergoing a uniform acceleration alpha, then rotational velocity is like, when we write v is equal to u plus at, what does it mean? It's for a linear motion. For a linear motion, the velocity is after time t is equal to initial velocity plus acceleration into time. Remember, this can be applied only when a is constant, that is acceleration is constant. In the same way, omega is omega naught plus acceleration into time t. You can apply this equation only when acceleration is constant, and it is given that it is constant because it's a uniform acceleration. So omega naught initial starting from s, so 0 plus alpha is 0.5 into time is 10, so it is 10 radians per second. So now we got omega. Now we can use this equation. So half into I is 2000 into 5 whole square. So that is nothing but 25. It's 1000 into 25, so 25,000, and that is nothing but 25,000 joules, and so 25 kilojoules. So the answer is 25 kilojoules. It's a very simple problem, just a mechanics problem. Thanks. 25 is the answer.